Welcome to the Out There channel, live stream 43. I'll just get rid of the echo, that was annoying. Just going to cover some recaps that I've done in previous streams and talk about Hollow Earth and underground cities tonight. So we'll wing it and on the fly. I'll just cue some music and be with you in a minute. So, got some people on already. What's going on here? Looks like I clicked something here. Let's have one. Is there something new they've added? How do I get rid of that? That never used to be there at the bottom. Anyway, it's never ending. New things changing. So, just transfer to there. Just trying to figure out how to kill the music too. Just trying to figure out why I've got all this extra rubbish at the bottom now on the Side Chet. It didn't used to be there. Not sure if you can hide it or not. It's kind of annoying having that there. Takes up most of the screen. Must be a way to get rid of it, surely. Ah, there you go. Must have accidentally clicked on that little button down there. Oh, well, you find out something new all the time. Welcome to the Up There channel. I've got to resize everything. Stream. If you want to be with me, I don't think Fridays works very well for people. I've got a big party going on next door too, so I don't know if you're going to hear any of it. They seem to think having outside speakers is a cool thing. Annoy the rest of us. There we go. I think we're back to normal here. I'll just check the sound. Whew, never ending, is it? So if anyone's out there, just say hi down the side. I think it's all working all right. So I'll probably carry on. Whew, there's always little technical glitches. So first of all, I want to recap Tesla's anti-gravity idea versus conventional theory of curved space. I'll just bring up the diagram because I think I didn't. It sort of got sort of not what do you call it? It's sort of like dishitched in places, and I went from one thing to another and had problems drawing. So these are the four base types of UFOs I was talking about, and how the shape is needed for a field to be able to do anti-gravity. So the key one we want to go for is the normal classic saucer. So I'll just get a copy of that. Let's see if I can explain it a bit better this time. I wonder, it really needs pull down, say, boot 1080p. Keep typing it in all the time. Anyway. It is free software, of course. So, I'll just paste our UFO to the image. Now, I'll try and explain it as I draw it. And then I'll get on to some other topics. So, use that one. So, draw planet Earth. So this is planet Earth underneath. And it's probably a little bit small though, isn't it? That's a big mothership. There you go. As you know, Earth has electromagnetic waves that go into space, protect it from solar winds. But that's nothing to do with gravity. Let's see if I can draw the lines. So if you think about Tesla said that gravity is the flux caused as the atoms draw in energy. As we know, atoms are constantly absorbing energy to keep them spinning, and we don't know where the energy is coming from. And he said it's coming from the ether, which is all around us. It's like a fourth dimension of energy field. And basically keeps atoms spinning. The atoms basically suck in energy from space. And of course, the mass of the Earth is more dense. So it's like magnetic waves, but it's going in the opposite direction like this. Of course, it's going to be dense. And it's absorbing from all directions. And the energy passes through all matter, all atoms, like this. Even the flying saucer. So if you can think about these flux lines being like current in a river, anything that's in that river is going to be sucked along towards where it's most strongest. So the key is for them to get out of this flow of energy. So even the saucer is absorbing energy as well, because it's made of atoms as well. So that's absorbing energy going this way. In all directions as well. But its own gravity is going to be smaller than Earth, and it's going to be not noticeable because in outer space you float, of course, and we've got spaceships, but the gravity is there. It's just non-existent, almost negligible, non-existent to the people. So the key is to make yourself transparent to this flow of energy going towards the planet, to make it sort of like buoyant. So the key would be, I probably need to undo some of these arrows again. Get back to the base. The key is somehow charge. Oop, I'm back too far now. I want to go forward again. Too many undos. So we want to basically bend the field around the craft so it's not actually in the flow of gravity or the energy being sucked. We want that again. So energy coming down, we want to sort of bend it around the craft so it still keeps going down towards Earth. It's a bit hard to draw with a mouse. And Tesla had found a way to do it with a rod, a cylinder. Have I got a picture? There's the four types. So he did it with a rod of, what did he say? The finest metal available. So I'm not too sure what that means. Maybe a mixture of platinum and gold. Who knows? Or maybe one of the other rare metals up there. So maybe he built a skin around this cylinder using this rare metal and charged it with high voltage. Maybe it created a field which sort of bent the flux going around it, which made it light like a helium balloon. So you can see where the shapes of the craft would come in handy. So that's a regular UFO. And if we did a cylinder, it's also got the shape where the field will be even. Yeah. So there's the cylinder. So no matter which direction it is, or size, the field's going to go around it. Same with the sphere, of course, which would be the more perfect shape. Hopefully that makes more sense now. So if you had a metal, a meta material, you could, which has certain crystal structures, which they say that UFOs that have crashed have meta materials, man-made, which have crystals in a certain structure, which could probably, when charged, cause a deflection. You know how some of the UFOs have a glow around them, so it kind of makes that if it's charged and the energy, including light itself, is being deflected around the object, it's going to give off, bounce off other light that's sort of heading towards it. Sort of like a mirror ball in a way, I guess. I think it's only how many UFO, regular cylinder UFOs have been glowing certain shapes, like the sphere ones. Not too sure on that. I kind of recall that UK one, he said it was sort of bright glowing, but then again he talked about panels of lights underneath, so yeah, I don't know. Let's have a, is it only the sphere ones that sort of have a glow? Not sure if you can hear the bass drum being played from the stereo next door. It's annoying. That. Need someone that's probably done some research to see how many were said to be glowing, which turned out to be unknowns, because a lot of, as we know, 95% of the UFOs turn out to be IFOs, identifiable. Strange yellowish glow. The thing is, we need to know which ones are really unknowns and not passing satellites or International Space Station, flares, and all the other ones that you seem to get out there. Well, if that's his video there, it's not going to show as much. Yeah, it looks like it's going to be. Yeah, I'm not too sure on that stats anyway. But yeah, perhaps if they that's probably why they can become also invisible. So instead of the light bouncing off the field, they may be able to oscillate the fields as they move at faster speed and then sort of disappear, because as they go higher, gravity gets weaker. So that brings us really to the other part of that, is what a satellite's not fall to Earth, and I'll just paste some links I got here. But I did searches. Why is that not opened? So a simple way is to do a search, of course. Save me having to type it. I'll see if it paste. So, why doesn't a satellite lose speed in lower orbits? Well, the easier way to explain it really is probably with a diagram. So this one here is probably a good one. Get around the ads. Slow. Looks like no one's joining me tonight. Oh, silly ad. Go away. So, someone here explained it properly. Why don't satellites slow down? And someone said they do. Let's take the ISS as an example. It loses up to 5 centimeters per second of velocity each day because of the continuing collision with gas particles. As you remember, the atmosphere of Earth doesn't end at 100 miles above us. It sort of keeps on going throughout space, and it gets thinner and thinner and thinner. Means bacteria could float on those gas particles into outer space. So it could survive the extreme conditions, radiation and temperature. So we sort of talked about panspermia before. So here he's got a chart of the changes in altitude of the space station over the years. So I guess they must use booster rockets occasionally to push it back up, or speed it up, I mean. Each vertical spike upwards is a thruster burn. So the burn thrusters here, is what he's saying. Performed to regain altitude because of the altitude lost due to deceleration. So when a satellite's spinning around Earth, if it's in a geostationary orbit, it's really also affected by gravity, even though it's weaker in the outer space. But because the speed of the satellite's going so fast, it's at crazy speeds, that the fall rate and the drop-off curvature of the Earth, it's always accelerating through to the movement and the curvature of the Earth. So this is why, again, flat Earth is debunked, because the satellites do go around the planet. So he says here, however, the higher the satellite orbits, the less deceleration experienced because the density of particles decreases. By the time we reach geostationary orbit, the deceleration essentially is negligible, which it would take decades or even centuries to have a noticeable impact. Now, the premise of the question is a bit flawed, in my opinion, as the satellite is always actually falling towards the Earth center at all times. The force of gravity is always acting on the satellite, making it fall towards Earth. But it so happens that the rate at which the satellite is falling towards Earth matches the rate at which the Earth falls away from the satellite due to the curvature of the Earth. The satellite just keeps falling off the edge of the Earth continuously. So a satellite always experiences constant acceleration due to the vertical component of gravitational force. Another reason is that compared to the size and mass, a satellite velocity is too high to be impacted by smaller interstellar particles, usually satellites above the atmosphere, hence no frictional loss there. And satellites don't carry a small amount of fuel to adjust their trajectory in case of imminent problems. So that's pretty good sum up there. And on to the next bit. Now, was there any? I think that one pretty much covers it. Apart from finding out how fast satellites go, what speed satellite. Geostationary. So that's why they launch rockets in a curved orbit as well. Notice how rockets always seem to bend instead of going straight up. If they try to shoot it straight up, it would never reach critical velocity to stay up. It would simply just come crashing down to Earth. A geostationary orbit can be achieved only at an altitude very close to 35.78 meters or 22.236 miles and directly above the crater. This equates to an orbit velocity of 3.07 kilometers per second or 1.91 miles per second, and an orbital period of 1436 minutes, which equates to almost exactly one sidereal day, 23.93 hours. And what do they say here? So we're talking about per second here, which is quite fast. When we talk about cars, we're going per hour. So what's that translate? Here, someone's written it out in per hour for us. And it's quite big. Satellites that are further away actually travel slower. The International Space Station has a low Earth orbit, about 400 kilometers, 250 miles above the Earth's surface. Objects orbiting at that altitude travel at 28,000 kilometers per hour, and that's 1,700 and 500 miles per hour. How fast do geostationary satellites travel? And they've got it in per seconds, which is, right, they've translated it for us. It's almost 7,000 miles per hour. This sounds about right. Someone said 10,000, I think. So that's quite fast. So as I was saying, I'm not sure if I covered it before. Why do rockets have to curve off? See what that comes out with. Steering technique is known as a gravity turn, which uses Earth's gravity to help conserve rocket fuel and minimize stress and strain on the spacecraft. This works by rotating the spaceship craft until its heavier side is facing down to help curve its flight into orbit. Why do rockets curve when they fly into space instead of going straight? Yeah. Shouldn't have clicked on that. Wanted a simple answer. Not another slow web page. Yeah. Probably not a lot of people know about all this, so it's good to go over it. Lay person's understanding. So as you see, the rockets always, even SpaceX, always start to curve. Let's put pop-up ads or something. So it says here, rockets something that can send people and stuff into space. Is a thin, cylindrical, very tall vehicle that launches from the launch pad, leaving a enormous cloud of smoke. Well, it's actually water vapor. In general, it could be, but it's not telling us why it's curved. Rockets are launched vertically with a tremendous amount of upward thrust. Following the launch, the rocket's climb is initially slow, but by the end of the first minute into ascent, the rocket is moving at a staggering 1,000 miles per hour or 1,600 kilometers per hour. While flying through the sky, a rocket loses a great deal of its energy as a result of air resistance. Why does a rocket's I think that's much of confusion about rockets' trajectory stem from the assumption that most rockets simply want to escape Earth's gravity and reach space. Well, this is not technically incorrect. It does not paint a clear picture. First off, you should understand that space is not that far away. You might want to check where does space begin. If you fly about an altitude of 100 kilometers, 62 miles above Earth, you are officially considered in space. The US Air Force word, what's it say here? Call you an astronaut if you flew above 80 kilometers, almost 50 miles. The main objective of most rockets is to reach the planet's orbit and stay there. In the planet's orbit, the gravitational tug of the planet is high enough to keep the rocket from drifting off into space and low enough so the rocket doesn't have to burn huge amounts of fuel to keep itself from plummeting. To enter orbit, a rocket begins to tilt onto its side at first and gradually increases this tilt until it achieves an elliptical orbit around Earth. That being said, attaining a proper orbit path is not easy. It comes at a cost of huge quantities of fuel that are exhausted to attain an incredible horizontal velocity of 29 kilometers per hour, 1,000 kilometers per hour, or 16,000 miles per hour. This technique of optimizing the trajectory of the spacecraft so it attains the desired path is called a gravity turn or a zero lift turn. So there you go. So rockets always have to do this. Then they simply slingshot around Earth and head off to another planet, Moon, or Mars, as SpaceX doing. Gradually build up the speed. So that also brings me to a thing called, a TV show called Strange Angel. I'm not sure if you've seen the TV show, but it's about Jack Parsons, who's the guy that set up Jet Propulsion Lab and was doing the solid rocket for aircraft, and also liquid fuel rockets. At the time, the Germans were also researching that with von Braun, but World War II happened, so they started looking at weaponizing the technology. So the show is about that, Strange Angel. It's about his life. It has some adult themes in it because apparently he was a bit of a cultist, but I think it was more that he liked the being a swinger, because it had a bit of sex involved in it. Strange Angel. So if you're not seeing the show, go and check it out. It's only 10 episodes, first season. It's a wee bit slow to start with. You need to get into the characters, I guess. Yeah, it's going slow. So we sort of got on a sidetrack here. But it's a worthwhile one. So this one here, you might have seen the cover. Yeah, it's already got a fairly good high rating there. But it's about, what's his name? Jack Parsons. And we've got a list of people here. Actors in it. So if you look up Jack Parsons, it's quite interesting. I see that the JP is his initials, and Jet Propulsion is also. I just wonder if they did that on purpose or if it just happened by chance. Which one? Yeah. Spell his name. I should have messed it. Oh, here we go. So I did spell it right. So he's a rocket engineer. So it's a 10-part series based on his life anyway. I think it might be from his diary or something. And there was a book written about him. So he actually looks quite like the actor, actually. So he's the man that set up Jet Propulsion Lab, because we were talking about rockets just before. So I'll just read out a bit about it here. His actual name was John Whiteside Jack Parsons. Obviously, they decided to go with his middle name for his alias. Was an American rocket engineer and rocket propulsion researcher, chemist, and thermite occultist. Thermite occultist, associated with the California Institute of Technology, Caltech. Parsons was one of the principal founders of both the Jet Propulsion Lab, JPL, and Aerojet Engineering Corporation. He invented the first rocket engine to use a castable composite propellant and pioneered the advancement of both liquid fuel and solid fuel rockets. And he wasn't a German, so there you go. I wonder why he didn't get to work on the project with Von Braun then. So what's this cult that he was with? Dynamite. Social or spiritual? Yeah. I think it's going to open up. Doesn't look too like devil worship. Kind of looks like a good luck charm. Social or spiritual philosophy? What's happened? Derived from Western historicism. Word itself is ancient Greek. regarded as a religion. So they're talking about love there. So it must be all the sex in it. Harmony from love. So yeah, I'll just chop that down. And the other one to check out also is the UFO movie. I'm not sure if you heard about it. I think I talked about it, didn't I? And I couldn't find a base on it. Well, apparently it's just called UFO. I was putting in first 10 minutes because it was called first 10 minutes, the clip. And I didn't realize it was just called UFO. But it's fairly obvious now. So why is it not clicking? It's just slow. So the movie here with Gillian Anderson playing a professor in maths. Anyway, it basically revolves around the magic number called the fine structure, which is 1/137, which is like a Fibonacci number where the spiral keeps going around into the center. Something to do with the energy released from a hydrogen atom, I think it is. But I won't go into it because it's quite technical. But you could probably Google 1/137. Because you'll probably be wondering what all the maths and the concept's all about, because it's not fair as Contact, I suppose, similar to the Contact movie. I'll post it down the side, the link anyway. I should have done the other one too. You can probably go and find it on a stream site somewhere and watch it. But basically, the story goes that the UFO emits a sound and he figures out there's a code in it. Basically, a code breaker of maths. And he uses constants of maths that we know in outer space to solve it without destroying the plot too much. So, yeah. But 1/137 is roughly the number, which comes out to that. And already it's come up with fine structure constant. Of course, this all comes down to also quantum field theory, and also, as we've got here, quantum field theory, Feynman diagram. You may know Richard Feynman. He was one of the guys that worked on the atomic bomb project. And I did a book review of his called "Surely You're Joking, Mr. Feynman." If you not read his book, it's quite entertaining. And he also, him and his wife did a bit of code breaking. They wrote letters in code, and he got in trouble with the government because he was meant to be not encrypting any of his messages in and out of the atomic bomb project. I'll see if I can find my link to the episode, the book review anyway. Just sidetrack on that one. So yeah, if we go to this wiki, I'll post it, because you probably need to understand a wee bit before you watch the movie, so it makes a bit more sense. But this goes in pretty deep, even the wiki page. You got the mathematics there, and blah, you know. But here's the number here, 137. something to do with the curvature anyway of the atom, which I'll talk about in a minute. Actually, I've got some updates on that. But while we talked about Feynman, I'll keep it all together in that grouping. For some reason, my book review got hit by downvotes, which is a bit unfortunate because it is a great book. Got hit by some secure 10 haters, I think. Crazy on your channel when you debunk them. Where is it? Here it is. Here it's got the book cover with his picture. I actually bought mine when I was at university, and I was cracking myself out laughing reading it during lectures. He's a funny guy. But if you're into science and getting into the life and mind of a scientist, it's a good book. Book to read. And I'll post that other link to that TV series so you can have a read there and do a search. It's easy to cut and paste from the Side Chet. It's going a bit slow, isn't it? Not sure if you're hearing that noise next door still. So that's Strange Angel, which is kind of a strange name for the show, but it's based on the book called Strange Angel. But man, my E key probably not working. Let's have a look. Oh, yeah. Here we go. Finally get there. There's all the links there if you want to check them out. So where were we? Before we went off on a tangent. So I was talking about rockets and trajectory and gravity related to talking about again Tesla's radiant energy, and the flux field is what he said was gravity, opposed to Einstein, who says gravity is from curved space, which no one can prove. And they try and prove it with the satellites losing time or gaining time as well. Yes, is it just losing time? I think it's just alternating time. They've got to sync it back to the Earth clock. But you got to remember, as we just saw, that a satellite in space, like a geostationary satellite, is actually moving all the time at, 7,000 kilometers per hour, which is quite fast, and it's passing through not only the Earth's magnetic field, which changes as you go out into space, but also it's changing the flux field that it's passing through, because the flux field gets denser as you move closer to the Earth's surface. So you don't have to deflect the flux field as much when you're further away from the planet than you are closer to it. A bit like your magnetic field, basically. Anyway, we only got so much information about Tesla and his research on levitating rod and some other papers. Apparently he wrote one on gravity, which I can't find. But Einstein actually believed in the ether. Up to the last minute, he changed it to what we now know as general relativity. So that was that done. So I was just going to do stuff on some atoms. Remember, I did a live stream on atoms. I'll just get links. Some things I found out since. That's a good one to start with. I'll look at that one first. I'll post it down the side too. This article here, when it loads up, do atoms last forever? What's the page though? I'm not sure if it answers that question though. I suppose atoms last for a really long time unless you shoot neutrons at it and cause a nuclear cascade called the atom bomb. But as Tesla said, atoms always absorb an energy from the ether, which maintains their integrity, the spin and all that. But here we've got an interesting photograph of an atom. First detailed images of atoms show various arrangements of clouds of electrons surrounded a carbon atom. A and B depict two different arrangements of the electron clouds. So even though it's the same atom, it's not just a sphere of electrons, it's also almost a, what would you say, a dumbbell of energy around, electron shield, a shell, what they call it. Did I post that one down the side? No, post it down the side. I talked about what atoms look like in previous streams, but I didn't find that diagram when I did it. I'm not sure how they did it, because when I click on the links, they don't exist anymore. What's happened here? What atoms look like? But they can only see it as a hazy, fuzzy outer, like this image here. I assume, and you can see it's sort of fuzzy. Not sure how they created that image. I think they would have fired the carbon atom at a charge, or fired stuff at the carbon atom and see how it bounced off, maybe. But I can't seem to find any information how they made that image. MIPT, Institute for Physics and Technology, Kharkov, is that in Russia? don't know, whereabouts is that place? So yeah, that was that one. Also got another one here. What's a shape of Electron? And it gets a bit more complicated. Where's the link? Explaining this one. So here's the first link anyway. Let me cut and copy it. Then I'll move on to Hollow Earth and underground cities as the next topic. So here we got a laboratory. The shape of Electron is surprisingly round. Probably have to skip it so you can read it. It's taking ages to come up. It's not scaling up very well, is it? All these side ads they have, that's annoying. It takes up half the screen. So let's see if we can read this out. Do I need to scale it up any bigger? Let's see. I'll probably scale it up. Electron against predictions appears to be perfectly round, raising questions. So what they mean is spherical, raising questions about one of the fundamental building blocks of the universe. Electron shape refers to that of a cloud of so-called virtual particles. So not saying the electron is actually a particle, but it's actually a hazy cloud of virtual particles thought to surround a dimensionless point. Scientists have predicted this cloud would be slightly aspherical as a result of from its positive and negative poles. But now physicist Johnny Hudson of Imperial College London and his colleagues have analysed the shape of the electron in unprecedented detail and found it to be as much as perfect sphere as can be measured down to less than a millionth of a millionth of a millionth of a billionth of a centimeter. So that's some crazy number, which would be 0.00000s, I guess. So how did they do it? And could it be flawed experiment? So remember I was saying they don't really know the shape of the atom. Already we're seeing it forms a dumbbell shape in a sphere, hazy, fuzzy filled, but we can't actually see inside it. And that was on a few live streams back. Which one was it now? When we were researching it and talking about it. So just find out what live stream it was. Slow. So I did this one here on the atom. Which was what? Live stream 37. And one before that was on how UFOs hover, which is basically what I'm recapping and updating tonight with some extra information. So if you've not watched those ones, go ahead and watch them after this one. So how do they do it? The researchers' experiment involved firing pulses of, how do we say this one? Iterum monofluoride molecules between electrified plates. The scientists then used lasers to measure how the molecules twisted within the electric field to deduce the shape of the electrons. They monitored 25 million such pulses. The difficulty is that we're trying to measure such a tiny effect. To put it in context, if you think hard and your neurons fire, they generate an incredibly tiny magnetic field. The magnetic field is big enough to distort an electron's motion to the extent that our experiment is spoiled. As such, they had to extensively shield their instruments against magnetic fields, including the use of metal shielding and custom lab equipment that doesn't generate magnetic fields. I suppose it used fiber optics, maybe. Although their measurements suggest that the electron is spherical, there is still wiggle room. The electron could be very slightly distorted, and with our level of accuracy, we would not have observed that distortion. The implication of our work is that the standard model of particle physics has not been disproven yet, and the theories that go beyond it have been constrained, but not yet disproven either. For instance, the new measurements put strong limits on one of the more popular theories to extend the standard model, supersymmetry. Not too sure how it disproves it. Again, they ignore that Tesla said electron's not the only electrical particle, but the radiant energy particle was the other one. He said that penetrated large sheets of steel and hit him in the chest and knocked him backwards when he reduced them. So what he was doing, he was trying to get it to, the ether to release a whole mass of radiant energy all in one go, and then try and trap it and convert it back into normal electricity. But radiant energy is always being released and absorbed into atoms, even our own bodies. So I guess it's a recycling of energy as such, in the universe, with his idea of ether that goes throughout space. So E equals mc squared, right? So matter should be able to be made from energy because E is the other side of the equation. So does that mean matter is really energy? So particles are really energy. Basically what I was talking about in that other live. It's a different way of thinking. And then how it relates to the UFOs topic, of course. And so I'll just bring up some other things on that particular experiment here. And you can see his papers online about it, how they did it. And this one, when it loads, measuring the electric dipole moment using ytterbium fluoride molecules. So there's the paper on it here, and it's got a few diagrams. Looks like it's almost like a presentation. So the molecule, I've got a picture of it here. They haven't got a picture of it. I'll bring it. We'll get a picture of it. Get your picture of the molecule with the single electron. Another tab. Where is it? Oh, there it is. So that's the molecule here. I'll place that down the side too. So it talks about the shape of it's got one electron, which I assume goes around the outside here, and its fuzzy orbit around those two elements or atoms. And it forms like an egg shape, I guess, like this. Fuzzy filled, showing it's rotating. So it's not actually a sphere. Looking at that there, if I'm understanding it right. But because it bounces off, all the bounce offs, eventually they can work out the shape of the electron that's orbiting it. And here's the equipment they use down here, picture. And all the vectors and angles and how it bounces off, diagrams here. So yeah, you have to be a bit of a maths whiz, I think. It's a bit beyond me, all this sort of stuff. I was never any good at calculus myself. I'm just trying to understand it as a layperson and trying to present it as a layperson. But if you want to get more into it, we got someone down the side here. Hey David, how's it going? Where are you from? Haven't seen you here before. Yeah, just not debunking tonight on this live. I'm sort of looking at various topics. So sort of percent how things are worked out in our current science and how it could be related to UFO technology. So we've still got lots of stuff to understand. And if we look at this quantum field theory, let's see, I've got a good post on Reddit here. Looks like it might be from some sort of spherical science. I know, astrophysicist here. So let's have a read what he says. I was only any good at computer programming and thinking outside the box. I was never any good really at calculus and stuff, but I did it at school and I got probably one of the highest marks when I did it. I think it was about 95% out of 100. And yeah, it's just a matter of just following rules and plugging in numbers. You don't really have to understand it, you see, but now we're trying to understand it to make sense of it all. And of course, a lot of it uses pi because it goes around on a curve. Probably people don't even know what pi is. I think I could find something easy to explain pi, actually. You're in Christchurch too. You've been here before. Normally I get a guy called Jamal from Auckland joining us, and a few people from America. So this guy here talks about quantum field theory. So the question was, are electrons, protons, and neutrons actually spherical? Anyway, I need a drink. When you talk for an hour, you get very dry. Electron has no height, width, or physical measurements. It is a dimensionless particle. So how can it be a particle if it's got no width, height, or physical measurements? You see what I mean? It's got to be energy, isn't it? It's got to be like a plasma ball of some sort when I read that. However, by our best current model, the electron is surrounded by a cloud of virtual particles. Now, that's also another crazy sort of statement. Imaginary particles that we don't know about. You know, I like to think that it's a energy in a ball that's sort of rotating and using like fractal maths to cycle its energy around, maintaining its structure. That's how I like to see how a sphere of energy would be myself. I had a picture on one of the lives previously, which causes some sort of field around it. So when you bounce it off other electric fields, it sort of forms the shape that they're talking about. The shape is currently a high sought after but unanswered question in physics, though current experiments suggest a sphere within error, which I just talked about previously. Asking what the shape of electron is a very tough question, mostly because it's currently ongoing research. So he goes into a bit of explanation there. What does our model suggest? The only way we can interpret the data is through a filter of a model. Current best model that we use is a standard model of particle physics. The mathematical framework for the standard model of particle physics is quantum field theory, QFT. An electron is a dimensionless point which has associated field, which is what I was saying, anywhere in space and any time. So now they're talking about space-time. So that's where it starts to get a wee bit unraveled for myself, because I like to think Tesla's explanation of why things curve is better than the space-time concept. There's always particle and antiparticle pairs popping in and out of existence. Now, I don't think there's anything like antiparticles. I just think it's just a normal particle that's had its spin changed. So if you crash in the CERN, a particle into another particle, atom, if you fire a neutron atom, it's going to fire, it's going to cause mayhem and cause them the normal, instead of the energy spin in one direction, it's going to spin the opposite direction. And of course, it's going to be attracted to the field in the opposite direction, which they would call antimatter particle. So I think it's this way that interpreting plus and minus and all that, I see it differently. I don't know if I'm correct, of course. I'm just suggesting out of the box thinking of different ways to look at things. Because at the moment, we're not progressing very fast in science, because we seem to be stuck on the space-time stuff. Einstein, even his E equals mc squared is not actually correct. Apparently, they reckon it's E equals mv squared. and some say that it's not the same as Einstein's one, and it has they've added some extra bits onto his equation. You can probably find out more information on that by googling. Is E equals MC C correct? And you'll find there's be a few videos on it. But you can see this guy goes into a big explanation talking about EDM. What was that standing for again? Standard model, was it? Electron standard model. Talking about how it was squashed, a charged body. So they can work out roughly that the shape of it was. So yeah, blabs on a bit there. But it's an interesting read. Again, this sort of relates to that UFO movie too, where they're talking about the mathematics and quantum field theory in it. I think that was all I was going to cover on the atom anyway. Yep. So that brings us to the next topic, would be underground cities. Already we've done an hour and 20 minutes here. So, did I read out this one? I did, yep. I'm no good at reading, as you see. Pronouncing some of the words can be a bit tricky at times, especially when you're wearing headsets. What was I going to do with that one? I was looking at. So I have done some other ones here. Apparently, this one here is banned in New Zealand. No, not that one. Where is it? So even though I'm in New Zealand and recorded it, this one here about mind control is banned in New Zealand. So I can't even watch my own episode unless I use a VPN or something. But that one was quite a good one. If you haven't watched it in New Zealand, download Epic Browser and you'll get around the IP problem and the blocking. It actually got 3 copyright strikes, that one. There was some music playing I didn't realize from a stupid website, from a radio station. Of course, it got flagged. And doing a fair use thing is a pain in the bum. Because I don't get any ads anyway, I didn't bother with it. And another one was a clip from a TV show that they showed in it and got a strike. And also another one from a TV, 2 TV ones. The contents ID system is nasty and it's tedious and it always puts you on the back foot. So that one there was interesting as well, on mind control, and also talked about EMF fields and how it affects the human brain. And that one here talking about invisibility, and we found out about a thing called quantum tunneling, which actually is real. So when we're talking about atoms being energy, you could see how if we ever figure it out, that we're actually be able to do quantum tunneling of any object, not just through a thin membrane like they've been experimenting with. So that sort of adds into the theory of why UFOs or alien creatures can levitate a person through the roof of their house. So that's why I've been looking at that sort of stuff with these guys on these live streams and sort of blundering or tripping over stuff, but that's the way it goes. Eventually we'll hoe it down as more stuff comes out. I think that's pretty much it on that one as well. So that was the image that they've said that they've got off the atom, the two atoms, pictures A and B. It's either that form or that form. So again, it looks like it could be a spherical type of object, the atom. So that sort of still stands for why the planet's a globe and everything spins around. It seems like Mother Nature likes to form spheres. Just makes sense. It's the most perfect shape, really, the strongest shape, and all that, you know. Why people think the world would be flat is beyond me. It's just sort of crazy. So, Hollow Earth. So, I was talking about this on a group last week, or was it this week? And he asked, could it be possible? And it was quite a good question. To get some image of what they're saying. Now, a lot of this stemmed from satellite images. See if I can get an image. Here's the famous one here. So there was some satellite images that was blacked out around the Antarctica, which suggests there was a black hole. That's only because of image processing. They didn't actually take photograph of the area, and they just put a black bit in. And also, people said on, I think there's the image here, of one of them anyway, where it had a hole on the image of the graphic they showed. You can see it here. They got grids also on the image. Satellite ESSA process it, because we know that there's no hole there because they got a base here in Antarctica. I think it's the South Pole, isn't it? This one. But we know we've been to both poles. You know, people have done video the whole trip and gone to the center of the pole and then returned back to the coast just to prove they could do it. But we know there's base up here that I talked about in the last live stream. So we know there's no hole like that there. So that's sort of debunked straight away. And on Google Earth, when you're on the outside space, it's also computer generated, you know, the cloud layer. If you go on Google Earth or maps in outer space, all this here on Google Earth, when they show it, is actually computer generated. It's not real time. It's not like taken from weather satellites where the clouds are currently. And some people say it takes a wee while to draw the Antarctican, and sometimes it shows up black. That's only because of the software. So if we have a look at this image here, the famous one, where they're talking about hole at the Antarctica and Arctic, with a sun in the center of the Earth, and probably oceans. Yep, oceans are here. Man-made tunnels. And what's this around the outside? Water, is it? Plastic basalt. Plastic basalt. Sediments. I don't know how someone came up with this diagram. Sources to Venus. Admiral Byrd's flight, 1947. Now, apparently, that's all fabrication. I did a thing on Antarctic stuff, probably a couple hundred episodes back now, where someone actually did a research project and wrote a big PDF on it, talking about the real facts about the people that have been down the Arctic base from military and the various projects. So let's see if we can find anything on Admiral Byrd. Oh, so it's come up straight away. Gives you the most searched stuff. Now you can see there's going to be a lot of YouTubes on this. So I'm not sure if I can find. The problem with the web, we don't know what's fictional writing and what's actual facts, because people keep reusing the same stuff and presenting it as a new video. So here we go, Skeptic Society. Now it's possible that they found a massive cave entrance and didn't actually go inside the Earth, so to speak, but they could have gone into a what do you call it, underground city. We know underground cities exist. My father only recently told me while he was working in the Air Force, he did some secret projects, and he actually went to an underground base in Germany, which was multi-stories deep, and it had electric cars and almost like a little city underneath. And as you know, if you ever watched Nazi Hunters, they went into some of these Nazi underground bases, and apparently then even they were not completed, but almost like it had an underground road system and massive thick concrete walls, and they're still down there. And if you ever watch the show, go and watch it again, because you could just imagine Americans and all other countries having underground bunkers like that with, 20 stories deep and lots of supplies, and maybe even if they got their own energy down there, even if it's thermal energy, as long as you got energy, you can drive UV lights which can feed plant life, so you can actually grow your own food. So I reckon it's all possible myself. But the Earth being hollow, no. But underground cities, I believe, yes. And also, if you had listened to Earl's mother's story, it almost sounds like my father's story, but they got an underground base in America desert there that she said was a mole underground. So look into that more in a minute. So here, Byrd claiming to see an opening in the South Pole. Was short on details. Admiral Richard Byrd didn't go to the South Pole in 1947. There was no such official record. So I think that's what I found in that video that I made a while back, but I can't remember what it was in PDF now. Some adherents to the Hollow Earth hypothesis believe that Byrd flew over the South Pole and into Hollow Earth in February 1947, and that he kept a secret diary. This belief was first published in 1957 in how do you say that guy's name? Guy Annie's book, The World Below the Poles. Writes that Byrd encountered a humanoid being from another world who warned humanity to pursue to pursue peace and not war. He also reported that Byrd spotted a living woolly mammoth near the South Pole. Well, I wouldn't discount that either. It might be frozen though. Might be just a thought form experience. So I'm not sure if I can find that PDF. But I posted a link on that episode anyway. So what are they saying here? Just scrolling through. So they're saying the story's not true because he didn't go. But we don't know what's been covered up though. That's the only thing. You know, with all stuff to do with this kind of UFO technology and underground bases, we know it's all covered up. What are you saying? You ever seen, what's it, Nazis, what is it now? Nazis at the center of Earth, or what is it? Nazis it's sort of like a silent movie, but it's a good piss take, and the effects at the end are quite funny. It has Hitler flying a saucer, but it's just his head attached to some sort of robot. It's kind of funny. It was meant to be a piss take of the other movie, Iron Sky, is it? Nazis base on the moon, which is also another good movie, funny as. So here, someone's asking, even last year, is there any evidence to debunk the inner Earth theory? Let's have a look at that one. It's taking a while to open. Practically, it's poor, as gravity doesn't work the way the idea requires. The inner gravity would be zero for the simplest versions. Spherical hollow Earth you can give a small gravity using flower pot model, but it doesn't fit descriptions. So they're disproving it with science here. Because we know the gravity is pulled on the outside, which I was talking about radiant energy. So if it was inside, the gravity would go the opposite way. Sort of wouldn't. Don't think it would work. Not too sure on that. I guess if you do space and time, it wouldn't work. But maybe actually radiant energy could well possibly work with a hollow Earth with having gravity. But then again, you need a big mass of material. And I know they've did scientific probing, and apparently there's meant to be a pocket of water in the Earth's core, which goes around the outer core of the Earth. What they're saying is perhaps all the water on the Earth is made internally in the Earth and comes up through those through the ring of fire, where it's sort of coming up in those big, huge, deep underground cavities. Internal Earth. They did some explosions and they can detect what comes back here. So here's some videos on it here. Massive ocean of water found 620 miles below Earth's surface. I guess that's from a news report, though. About 71% of the Earth's surface is watered, and the oceans are about 97% of the Earth's water. Water also exists in the air as water vapor, in rivers, lakes, ice caps, in the ground as soil moisture, and in aquifers. But that's not what they're asking, though. Deepest water found 1,000 kilometers down. How much did they say at the top here? 260. So that's the same thing. So let's have a look at that one. So that was back in 2007 that they reported on that. So that again sort of leads to the idea that other life could actually be living in the sea. As you know, 1% of the world's oceans is only explored. So if they got water that also under the Earth's surface, and that much of it, why couldn't there be life in it? We know that some life can live extreme temperatures over boiling point. I think it was 117 degrees Celsius. So yeah, I'll just go to that other link. I wonder if there's a picture. I'll see. We'll go to this link. Where is it? Life Science. They generally have good stuff on their page. So they're saying pockets of water here. There's so much of the universe as well as our planet we don't know. So here's some images they've got. Not the best of images, though. Can't read what they say. Scientists scanning the deep interior of the Earth have found evidence of a vast water reservoir beneath eastern Asia that is at least the volume of the Arctic Ocean. So that's quite a lot of water. And discovery marks the first time such a large body of water has found in the planet's deep mantle. Finding, I don't want that playing. Why'd they autoplay videos? That's really annoying. Finding made by Michael blah blah seismologist at Washington University. His former graduate student blah blah blah. San Diego will be detailed in the forthcoming monograph to be published blah 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 blah. So it's all pats on the back. Looking down deep, the pair analysed more than 600,000 seismographs records of waves generated by earthquakes travelling through the Earth, collected from instruments around the planet. So there you go. So that surely then cancels out also the hollow Earth of being reality, but doesn't sort of counter out there being life down there. Because you got the energy from the Earth's core generating energy, which we know is because we've got lava. So it's generating energy, and if you got microbes, there could easily be life down there. Reptiles. So yeah, it sort of doesn't disprove anything apart from it being hollow, but it could be just undersea ocean there of some sort. And of course, lava obviously would flow around it. But if you have a look at, we looked at the temperature of lava, and it's not that hot considering how hot is lava. And I think it was about 1400 C, wasn't it? Where is it? Oh no, not quite that hot. Oh, hang on. Where's it's in Fahrenheit? Why can't I keep it into Celsius? But I think it's 1400 C, wasn't it? Here we go. Gets hotter than 1600 Fahrenheit, so that'd be 1400 C. And as we know, how would you be able to protect yourself from that heat? Well, they've got water underneath there. As long as you've got water, you can cool off a cavity that goes around a city, couldn't you? Or an underground base. Because as I get further down, it gets hotter. So, what materials can be fit to finds it? Lava. There'd be quite a few. So here we go. What materials can withstand lava? There are many materials that withstand these temperatures, from metals, nickel alloys, iron alloys, tungsten, and I don't know how you say that one, even though these two might have oxidation issues. Iridium, osmium, titanium, which is quite a common one used in military, to ceramics, silicon nitrate, aluminium oxide. So you can see there's a lot of elements where you could build a big thick wall that can withstand even the hottest part of the earth coming up through the ground, lava. Unfortunately, there's no material on earth that can withstand landing on the sun at this stage. The sun's surface was, I think it was like 4,000, 4,500 degrees Celsius, and the metals that can't go up that high. They start to melt. And as you know, metals are actually crystals. So if you say here, say metal, crystal. As we know, crystals are used a lot. Here you go. The scientific definition of a crystal is based on the microscopic arrangement of atoms inside it, called crystal structure. Most macroscopic blah blah solids blah blah, including almost all metals, ceramics, rocks, etc. Sort of cuts off, but yeah. What is the structure of metal crystal? There are 14 different types of crystal unit cell structures, or lattices, are found in nature. However, most metals and many other solids have a unit cell structure described as body center cubic, face centered cubic, or hexagonal close packed. So look, that's the one there of a metal. So just put that in there in case you didn't realize metal was a crystal. So really, Hollow Earth is no, but underground cities is probably a yes. We know humans living down there, at least a mole underground anyway. And we know there are some huge caves. Did we have some questions down the side here? All right. We sort of moved on from the Admiral Byrd. Underground caves. The once largest underground cave. So it tells us. And here we go. Largest cave in Vietnam at more than 200 meters high, 150 meters wide. So these are natural caves, not man-made ones. So images. So here's some caves. And you can see they're quite big. And the most interesting ones are these ones with these huge crystals. 10 famous underground caves. They have these huge crystals. There's the people here. See how big they are? Calcium, I think it might be. Kind of reminds you of those sci-fi movies, Journey to the Center of the Earth. If you've not watched those early classic ones, go and dig them up because they're quite fun. And To the Earth's Core, I think, was another one. Great movies. So if that's way underground, so if we can find how deep it goes, I think it goes a couple of miles underground. I haven't explored it all. And what happens is a lot of them are made through lava tubes. So when lava comes up and then it changes course, these lava tubes with these cavities where crystals form by dripping water and minerals in the water. So here's one. I guess that's snow. Ice giants. Underground caves. A cave of crystals was discovered. Let's see if we can get it. In 2000 by miners. A new tunnel for a mine in northern Mexico. Let's see. Does it tell us how deep it is? So what's that one called? So it gets quite hot here, see here? So large because of the extremely hot temperatures inside the cave reaching a steady 58 degrees. So if you have an underground city, you've got to keep it cool, which is possible. You could build those metal structures around, and you can make it so it has water that sort of flows around inside a pocket around another metal. So metal, a box or whatever, a sphere with another sphere that's bigger, and always pump cold water around, a bit like a radiator of a car, and you'll be able to regulate the temperature. So I think it's all possible. What do you think? Anyone out there still? How far underground can you go, though, is the question. But you can see there's a lot of caves. What was the crystal one called? Cave of Crystals, okay. I want a map, see how deep it goes. How deep? Right. Connected to a mine at a depth of 300 meters, 1,000 feet almost. The main chamber contains giant selenite crystals, gypsum, CaCO. So it wasn't calcium, or was that top of calcium? Ca is calcium, isn't it? Have we got a map? I want to see a map. Getting those ones again. They must have mapped it by now. So that's 1,000 feet. Is that? That would be like a mile underground, wouldn't it? Let's type it in. 960 feet. See if Google Calculator comes up. 300 meters. Oh, that's only one third of a kilometer. I thought they measured it down to a mile when I saw it on a documentary, though. So if it's 58 degrees, even at 300 meters, it's going to get a lot hotter as you go further down then. So that's the only thing that makes it impossible to live underground is the heat. It's too hot. As you know, the heat wave in UK at the moment was in the 30s, and people found it unbearable. Imagine being 58 degrees Celsius. What is the deepest cave? Or tunnel? I don't know. So here we go. One at 2 miles. The Krubin, how do you say that? Krubera Cave. It's the deepest on Earth, located in Arabka Massif, Western Blur. I don't know how you say all these words. Georgia extends so it's 2 miles deep and 2 kilometers deep, and it runs for 13.5 kilometers long. So let's see if we can find stuff out on that one. So there could easily be a cave in the Antarctica, even the Arctic, that is like these ones here. It says there the second deepest when I just read it. It's the second deepest known cave, so they must have found one since. Complete map. That's what we want. So if these are naturally formed, Why couldn't there be life under there that sort of adapted? You know, if a meteorite hit the Earth, people would probably go underground. And if they were underground long enough, if they went deep enough. But the thing is, how would they get oxygen? So they've got to have some sort of algae, some sort of water system, and algae's got to feed off some sort of light. So you've got to put all those factors together, I guess, and see if you can prove it scientifically, whether it's possible. And I think it's possible. So here's a map of it. Wow. So the Eiffel Tower is next to it here. So this is how much the cave people have mapped so far. Goes a long way. Still going down. Underground camp. So they even go down that far and camp. Another one. So how'd they get oxygen down that far? That's the question I want to know. So 2 kilometers, and it's still going on. They still haven't finished mapping it, by the looks of it. Towards the south of the Earth. So that's quite interesting. It looks like a lava tube, you see? Looks like it was a lava tube. So how do they get air down there? Do they pump it down there? Because normally you have the toxic gas, don't you? Maybe I should give you the guy's link. I want to have a look at it. Deepest cave tunnel. Well, it's cave and tunnel. It's a natural cave. So what I want to know is how this oxygen how far does oxygen go around? I didn't find anything. So they're talking about oxygen, carbon. How deep could a human go underground before heat pressure? Let's have a look at that one. Yeah, server error. That's a shame. So what they're saying about underground mining here. Air has a lot of trouble circulating far underground, even if it weren't. So that's a bit like the space shuttle, because there's no gravity, and they have to use active air pressure to push it through the space station all the time and filter out the carbon dioxide that builds up from breathing. In the past, ventilation in underground mines was a serious problem. Coal miners during the early 20th century were susceptible to carbon monoxide poisoning and other hazards while performing their job. And the birds, with their high metabolism and accelerated breathing, were more susceptible to the gas that miners, and their unfortunate deaths would give time. Because you can't actually smell carbon monoxide, can you? It doesn't have a smell to it. Ventilations are extremely complex and have to work extremely hard. Electricity needed to run the fans. So that means they must have pumped oxygen into that big deep cave before they could enter it and take breathing oxygen tanks for them. How would that work? They got those camps 2 miles below ground. They wouldn't be wearing masks all the time, surely. They must be pumping the air right down to that level. And they even got dust monitors, because chronic exposure, I suppose it's a bit like asbestos. Dust causes lung diseases and can lead to permanent disability. So you got coal dust, and used to kill a few people. Heat. As most people know, the inside of the Earth is a giant ball of molten rock. On the surface, this doesn't pose much of an issue apart from the odd volcano. But once you start digging a long way down, residual heat from the Earth's core can start to become a serious problem. In most underground mines, this sort of heat isn't really much of a problem, since the digging doesn't extend deep enough to feel the effects. However, some super dig mines in the world, such as the gold mines of northeastern South Africa, reach so deep underground that the rocks the miners are drilling into can reach a staggering 66 degrees Celsius, over 150 degrees Fahrenheit. In normal circumstances, working in such conditions would be impossible. Where technology comes in. Super deep mines such as Moping gold mine, which extends 4 kilometers underground. So that's interesting. Uses a variety of techniques to keep things workable. First and most significant is constant circulation of slurry ice. The special ice isn't the sort you grab from the supermarket to barbecue, rather more advanced and simple frozen water slurry ice, specially formulated to cool longer and more efficiently than other forms, and helps keep temperatures. So if they've gone 4 miles deep with a coal mine, could they even have an underground city for up to 4 k's deep then? As long as they can cool it, which is what I was saying previously. So how deep, that brings us to the next question. So I'll just post that one there, because that's quite an interesting thing about mines. Deepest mine. So the deepest natural is 2 kilometers, and the deepest mine is 4. Probably bored a lot of you off by now, probably. How many watching? Oh, 4 people watching. See, I don't know the stuff, so I'm sort of researching it on the fly with yous. And it's quite fascinating, I find, myself. Because to me, that suggests it's all possible to have underground cities, even in Antarctica. So where it's very cold, living underground makes sense, because it's going to be warmer, of course. until someone can prove there's a cave system or underground city there, that's another thing. So, what was the next thing we were going to look at? Forgot what I was going to cover next. So obviously, as long as you've got enough power as well. But if you've got geometric, geothermal heat from the Earth's core down there, or lava, you could easily heat some water into steam. So it could be part of your cooling system even. So as the water heats up around your shell of the city, it then could turn into steam, power generators, which powers the whole thing around again. And then you're pumping cooler water right around, a bit like a nuclear power station in effect. I don't know if there's any known underground cities. Underground, never know. Someone may have documented one or built one. Underground city. 9 secret underground cities in the world. Let's have a look at that one. 14 fascinating cities that are found underground. That's last year. Underground cities you didn't know exist. And that was also end of last year. So let's have a look at that one first. Hey, we've got someone else on. Forward. This must be a record. Record for what? NG, what's that? National Geographic. So, what underground cities are they talking about here? A huge underground networks may not see the light of day, but they have been pulling visitors into the subterranean bowels for centuries. Is that the one that's under France? So we've got a salt here, Poland. One of the most visited attractions in Poland. Kind of looks like medieval, doesn't it? Underworld for occults. What else we got here? Where's the 10 that's talking about these ones here? It's not a really friendly site, is it? So there's another one. Oop. It's not a very easy site to navigate. But you got to click on the images down here to see what it is. It's saying now it's finally loaded. So this one's in Australia. Coober PD, Australia. Town situated in southern Australia is best known as an opal capital, but what seemed more impressive about it is the local population of 1,500 moved their life underground to escape the daily heat. So they build out of these mines underground houses, which they connect into a city. So they even got a chapel that they built. So what was the next one? Edinburgh Vaults. Yeah, we know about that one. A lot of ghost hunters use it, don't they? Next one. What's going on here, Ford? I don't want to have to ban you for stupidity. Mate, I'm falling asleep. Yeah, sorry, mate. What is the time? 1 o'clock. You have to get used to my hours. But I will be wrapping up soon anyway. It's been going over a couple of hours now. But you can always watch it later anyway. So what's this one here? Turkey. Oh yeah, the famous Turkey one. Apparently they have stone wheels that they roll across to keep the intruders out. These structures under Turkey are massive as well. But they're not very deep. So there's more here too. What's that one there? That doesn't look like an underground city, but it could be. Canada, the looks of it. Yeah, it's not loading. It's going a bit slow. Looks like it's opened up differently though. What's that one there? Is that underground? Could be. How do we get more information on it? Oh, right. So what's that one there? Atlanta, Georgia, USA. This city beneath the city was first constructed between 1866 1871 to accommodate the increasing population of Atlanta at the time. It was until 1969 that the place was rediscovered and turned into what we call today underground Atlanta. These 6 blocks, 12 acres, and 3 levels of shops, restaurants, and entertainment now make for one of the liveliest and hippiest places in Atlanta. So there you go. Looks like a good place to, even for doing movie sets. Of course, they get a lot of bedrock in those countries, and that's nice hard rock. And of course, you get limestone, which makes those sinkholes in Florida as well, where that guy got sucked out of his bedroom one night, went underground. I never saw him again. All the soil poured in after him. So yeah, there you go. Underground cities do exist. I was going to click back, wasn't I? So what was the last search? I was going to have a look at some of those other links. Have a look at that one now. What are you saying here? Remember, I said if you troll, you get banned. That's your last warning. So, 14 fascinating cities that are found underground. Now, we're only interested in people that are really interested in this stuff. Hollow Earth, underground cities, whether it's possible or not. And that's what we're looking at. We don't want no people here clowning around. You're going to have to go. You were warned. See you later. Okay. So we got some other stuff here. Toronto, Canada. Tuscany. Cave dwellers. Look at this place. Of course, there are underground tubes. Why is that not blocked? Might have to. Alright, let's start to hide it, is it? I guess there are underground places in Giza, looks of it, which makes sense. Because a hidden room in, I think they found in the Great Pyramid, which is quite an interesting story. Have you seen the reboot? You know what a reboot is when they redo a movie but with new actors and use a new storyline. Well, if you watch the latest reboot Tomb Raider, they also go into an underground city in a mountain to see this death crane, as it's called in the movie. It's not actually too bad. It's quite good for a UK movie, UK/USA movie. It's a bit like Indiana Jones, and they step on things and trigger things, so it's quite good. I notice it doesn't tell us how deep it is. And all these. So here we go. Massive 5,000-year-old underground city uncovered in. How'd you say that word? Turkey, is it? So that was only back in 2014, was it? When they discovered it. Consisting of at least 7 kilometers or 3.5 miles of tunnels, hidden churches, and escaping galleries dating back around 5,000 years. So it was only found in 2014, that place. So built into the hillsides here, I guess. Cappadocia, Turkey. I suppose that's how you say it. Here's an image of it. Wow, it is definitely an underground sorts with streets and passageways. And linking to other tunnels inside other houses here by the looks of it. Wasn't there something like that for America? Didn't they have something underground like that? Let's have a look. Underground tunnels. So there was actually meant to be tunnels in the Port Hills here as well. See, it's talking about Wellington. It is quite hilly there. And America. So if that's a map of tunnels in America, there's quite a lot of them. Let's have a look. What's it saying? It's not very clear. Oh, right. That's a computer game, isn't it? Egyptians. Yeah, I don't think we're going to find much, but it does look like there's a lot of tunnels for they use for rail. And here's the cutting machines they use. And they're massive. I think a lot of it was to do with the underground rail travel anyway. Let's have a look at that one there. Under Kansas City. There you go. More than 1,000 people spend their workdays in subtropologist and international park housed in a excavated mine the size of 100 football fields. So there you go. About 10% of Kansas City's commercial real estate is underground. So I didn't even know about that. So how far does it go underground though? What kind of rock would that be? Colored granite or limestone? 100-foot high ceilings. 140 million year old limestone. I doubt those. That tells us. So long as it doesn't get wet, I guess it's going to be safe, because we know that sinkholes happen because when limestone gets wet. What's that? A computer facility. There's two. Look at that. Good way to put a cloud server bank of a lot of the human records on there. Major data center, it says here. You can bet the government have got lots of these, and NSA was building a lot of data banks like that to spy on everybody. So all this is underground, though. So it's like a little factory under there. So we've got computer, industrial, printing. Oh, that's pretty cool. Let's get a closer look at that. That's pretty clever. Good artwork. You think they'd have LCD screens on the wall that sort of emulates it, looking at oceans and stuff, so people feel at home. So they're storing film tapes under there. Original film from Gone Off the Wind. So all that's just Gone Off Wind. It's just crazy. And what else we got here? Coffee. So food storage. What's that one? Assembly plant, Ford manufacturers. There you go, building cars, is it? Manufactures steel bodies that get rigged onto Ford trucks. So they're putting stuff on the back of the trucks by the looks of it. So what else we got? Forever expanding, I guess. Well, I wonder how safe it is from a nuclear explosion. Doesn't say how deep it is, though, anywhere there, does it? I didn't see it. What's it called? It could be called subtropologist, I guess. Well, it can't be that deep because it would get hot. So how deep? And they're just using limestone. So obviously walls and water cooling. It's air ventilation blocks of it. Do that. Canvas, was it? Let's pull it up. Work it out. Let's have a look here then and see how deep it goes. Does it tell us? That's not about the temperature. It doesn't tell us anything, does it? So it's the world's largest underground business complex, but it doesn't tell us how deep it goes. Yeah, I probably covered enough on this. It's just interesting stuff at the moment, just looking at places. So it's 160 feet. So it's not that deep. There's a good way to use an old mine, I guess, turn it into underground businesses. Okay. So I'll probably wrap it up there for this live stream anyway. We'll probably do another part on it another time. If anyone else has find anything interesting about Hollow Earth and living underground, by the looks of it, it's all possible, and currently people are living underground as long as you've got energy and water and food and oxygen, of course. But the question would be, could you make plants live under there? I suppose if you've got UV lights, would it produce enough oxygen? That'd be a good way to test, wouldn't it, before you go to Mars, is have an underground city and sort of have everything working underground before and duplicate it on Mars. Also, it would make sense to build an underground city on Mars and the moon if you're going to go up there instead of building on the surface. So, yeah. Of course, they said a lot of people think there are underground cities on the moon as well, don't they? So, but we've yet to prove it, or it's been hushed up or covered up. So, yeah, thanks for joining us tonight, guys. Do give us a thumb up, share it. It wasn't organised, it was just a research live episode mostly. So I'll just change the screen here and roll off the credits. And thanks for joining us.